Hi guys, today we're going to introduce our work for assignment 2. So first I'm going to introduce our dataset. There are about 430 Excel sheets in our dataset, and each one contains 53 features and they're of different lengths. For example, there are 89 rows in this file and there are only 20 lines in this file. So first of all, we're going to pre-process the dataset. First, we're going to extract only the valid columns because we're only going to use the face and arm features such as nose, eyes, and ears. And then we read the dataset into the MATLAB in this section, and then we read each this file into a matrix and reshape the matrix into reshape each matrix into a vector. And then we do zero padding for each vector because if all those vectors are of different lengths, then the classification learner would not accept such features. So we save the pre-processed data into the datum.mat, and later in the classification part, we're going to load the dataset we have pre-processed and then get labels. If the label of one vector is about, then we assign it to be 1. If it's farther, then we assign it to be -1. And then we shuffle the dataset and split the dataset into training set and test set. So here I'm going to do all those previous work. And then we use the classification learner in the apps to do the classification over the training dataset. So we import the training dataset, and later the response is default to be the last column, which is our labels. And then we use all those 3,000 features to start a session and do training on a linear SVM. So we can choose the linear SVM in this part, and then we click train. And after training, we're going to export model. We already did this part, so we're going to just load the pre-trained classifier, which is in the trained classifier.mat. So after we open it, we can see all those parameters stored in it, such as the alpha, the beta, and the kernel parameters. So since this linear SVM used a linear kernel, so we cannot just simply use the beta and bias to do the classification. Instead, we are going to compute the weight vector based on the alpha, the support vectors, and support vector labels. So, and then this weight vector and along with the bias, along with the mu, which is the main vector of all those features on the training space, and sigma is the SDD vector on the training space. So later we are going to store all those parameters into a file, and then we read this file into the Android to use these parameters. For now, we are going to do prediction, use the trained model on one of the test dataset and to see the time for the prediction on MATLAB. So we have done several predictions, and we can see that the time that MATLAB needs to do prediction is around 0.25 seconds. And now we are going to do our classification, our prediction on the Android project. So this is the Android project we have already developed. it's pretty simple, only one class in it, which is the main activity. So first of all, I want to show you the interface for doing this project. So simply, at the first, this app would introduce our application. So we are going to extract the parameters from the pre-trained SV model, and then we select any Excel sheet and extract features from it and predict label. So let's first extract the parameters from the SVM model. So it tells you that there are 5 parameters we're going to use in our prediction, and then we can choose any Excel sheet and do the prediction. So it says the soft label is positive. That's why we're going to predict the label as about. And indeed, this Excel sheet is about. And the test time on the phone is around 5,000 microseconds. So it's much faster than the prediction on the MATLAB, which is around 0.25 seconds. So the reason might be because it is very time consuming for MATLAB to invoke or to call the prediction function in the MATLAB. So now we're going to walk through the codes for our Android. So first of all, after we clicked on the extract parameters, the Android project calls this function, which is called getParams, and then we read the parameters that is stored in the raw folder, which is called params, and then we read the weight vectors, mu vector, sigma vector, and gamma and bias variable. And then we also get the list of valid feature indices, because later we're going to use it to extract the features from the Excel sheet. So, and then after we selected any Excel sheet and click on the prediction button, then the project calls this function, which is called predict. So in this predict section, it is going to recognize the Excel sheet that you selected from the spinner, and then for each different selection, we are going to do a prediction on a different Excel sheet, and then we extract the features from each sheet, such as we extract features into a row feature whose length is 3080, which is what we used for the MATLAB training. And then we start the prediction. So we set a start time here for this, and then we calculate the soft label based on the dot product of the w vector and the normalized x vector, and divided by the square of gamma, and then we add it to the bias. This is the soft label we calculated. If it's positive, then we assigned it to be about. If it's negative, then we assign it to be further. This is how we did prediction on the Android. And then we end the timing and to see the difference between the end and start time, and to see the time spent on prediction on Android. So as we can see here, the time is like faster than MATLAB. So this is our conclusion for assignment 2. That's all.